Right then, ladies and gents, boys and girls.
Gentle boys.
Gentle boys, okay.
That's not a thing.
Did I say gentle boys?
Yeah.
Oh, I didn't.
If you think you said gentle boys, put it in the comments if you think you did.
Right, we're going to have to speak up because I've forgotten the microphones. So we're going to have to speak up today. So today we are at...
Kennedy Space Center
Kennedy
in NASA in Florida.
Yep, as he says, Kennedy Space Center, Florida. We're going to have a look around, see what's what, learn a few things.
Maybe.
And hopefully we'll be able to pass this one on to Meadowside School. So hello, Meadowside.
That's going to be better than school, isn't it? That, you know,
What's your class name? Do you have a class name?
Year 5.
Year 5. Hi, Year 5. So we're going to enter NASA and see what's what.
I don't know if it has a name or not. Lost.
It doesn't surprise me. He doesn't listen to me either.
Yeah.
Heroes and legends. One thing I love about the Americans is they don't like to understate things. Heroes and legends. So we are going to find, I believe it's a theatre. This is what we've been advised to do, is go to the theatre and actually watch what, basically I think it tells you what everything's all about, all the rockets and stuff. And then that will help us throughout the rest of the day to work out, what's what, because we'll have had a bit of education.
I gotta admit, you wouldn't expect a serious rocket company to have a rocket that has a smiley shark face on it.
A smiley shark face on it. Where? Oh yeah, I didn't see that. You're right.
Daddy, stop!
It's quite cool, isn't it? The size of these things.
They're huge.
Right.
Oh, that one's got its open. Oh! It's got a rocket stuff right.
Right, so I think we're heading over there to the IMAX theatre. I don't know what that's supposed to be. I'm guessing that's supposed to give you an idea. Come on, Theo, run up. I think that's supposed to give you an idea of what the space capsules even used to be like. Imagine being sat in something like that for hours and hours and hours, days.
Yeah, I can live.
But then it would be peaceful for the rest of us.
It'll be interesting. There is a bit of water in there, I must say.
Oh well, okay. This is... So Theo, if you stand next to this rocket, and that gives us a nice size reference. So Theo walks up there, and then we'll go up, up and away. That's insane. It's quite amazing to get right up and close to these things, isn't it, dude?
Yeah.
To think that this stuff has been in space, orbited the world.
It's been in space.
Yeah.
How's it not been
I think
wrecked?
all of these have gone into space.
How have they not been wrecked?
Well, they're built to come back. So we're literally just heading towards the IMAX theatre. It looks quite quiet today. We've got here relatively early doors, which I think has helped. But it's not silly busy, is it, mate?
No.
Which is quite nice.
VR experience.
Hey?
VR experience.
Yeah, I don't know if that's what we're doing now or not. I'm not entirely sure. But there's another rocket. Wow, look at the size of that. It's quite amazing, actually.
I mean, that's like massive.
Insane.
I mean, how do you
Right.
send them up into space that big?
The world's largest space shop. Go in there in a bit. Have a look what's what. That's pretty cool.
Yeah. Isn't it?
So that is, let's have a look. Let's do a little bit of education. Going back to rockets from the shuttle. Payload. Wow, so people would have lived in that, would you believe? That would have been cozy, wouldn't it? Get to know people very well in that. Wow. You're going to be friends with someone for a while to be staying in that with them, aren't you?
right, so the first thing we need for our sandwich is a piece of bread. Well, up here we don't have bread like you do on Earth, but we have tortillas. So we use tortillas a lot for sandwiches. So that's what I'm going to use for my peanut butter and jelly. I'm going to stick that down in some tape here so it doesn't go floating away while I'm getting everything else ready. So I'll get my peanut butter on, and even the lids on the peanut butter have a piece of Velcro on it so they don't go floating away. If I let it go, it'll kind of just float there for a little while, and then eventually the air conditioning system here will take it away somewhere else. So I don't want to lose it, so I'm going to stick it on the table. I'll scoop out some peanut butter for my sandwich. I got to stick this somewhere, otherwise it just goes floating away too. But just for now, if it's just a few seconds like this, I can just leave it, let it float. I'll spread the peanut butter on my sandwich. The tortilla. And then I get my jelly ready. So a lot of things you got to think about and manage while you're eating up here. And you just spread the jelly on the sandwich. That as well needs to get attached to the table. So there's my peanut butter and jelly tortilla or sandwich. Up here, I'll just kind of close it up and enjoy. See if you guys can enjoy it as it's coming to you.
Are you gonna have it?
If a ship of aliens came across this object floating in space, what would they think? From the big mirror, they might guess it was a telescope, built by a curious species for taking pictures of the universe. But they couldn't know that it took 10,000 people from 14 countries 20 years to build it. Or that it was designed to look for the beginning of time and space, until it started looking for them.
telescope anyone's ever built. One of our reasons for being is so that we can do these good and interesting things that move us forward as a species. I think everybody wants to be a part of something greater than just what they can do alone. Building something like the JWST is that.
It's amazing for me as an astronomer to work on this project. JWST is the next huge step in furthering our understanding about the universe. It's almost like there's a curtain beyond which we can't see. The telescope is going to allow us to lift up that curtain. This is a telescope to help us understand who we are and how we got here, and the big picture of how did it all come to be.
For thousands of years, people thought the Earth was in the center of the universe and everything revolved around us. But in 1609, the astronomer Galileo raised his homemade telescope to the sky and found evidence supporting the idea that we're actually going around the sun. We've come a long way since Galileo, and telescopes have gotten more and more advanced. We now know that the sun is an ordinary star in a galaxy we call the Milky Way. A spiral of 200 billion stars, so big it takes light 100,000 years to cross it. Until now, the most powerful space telescope was the Hubble, and it found more galaxies than we ever knew existed. Some of them are so far away, it took their light billions of years to reach us. The universe began with the Big Bang, 13.8 billion years ago. This was the beginning of time and space, and it happened in an instant. For a short time, the universe was only made of hydrogen and helium, and it glowed like a warm campfire. Then, for several 100 million years, there was nothing to see. Slowly, under the force of gravity, tendrils of material began to coalesce, and the first stars and galaxies shone forth.
Galaxies grow. But it took a few 100 million years maybe for the first luminous objects to occur. The first stars, the first galaxies, the first black holes, whatever it was. So our idea, one of our most challenging projects for this new telescope is to look for those first things.
You know, we wouldn't have built the telescope this big unless we needed to, and you need to build a telescope this big if you want to look at the very dimmest, most earliest galaxies in the universe.
The mirror is 6.5 meters, or 21 feet in diameter. And the problem with a mirror that big is it wouldn't fit in a rocket. So they had to build it in lightweight segments and figure out how to fold it up. The earliest, most distant galaxies in the universe can only be seen in infrared light. Infrared light is heat, and to detect it, the telescope must be kept very cold. It must be completely shielded from the sun, and that was a whole different kind of problem.
We don't want the telescope portion to see any of the sun. So this sun shield is a really good SPF. It's about 1 million. What was particularly challenging is the fact that we have to fold it up and deploy it once we get on orbit.
It's an engineering marvel. The sensitivities and the requirements for doing the science correctly were so difficult that one would say it may not be possible.
The telescope was originally set to go to space as early as 2011, but things kept going wrong. The cryogenic cooler for one of the instruments failed. The sun shield developed tears. And at times it looked like the telescope might never make it to the launch pad.
When you accelerate from 0 to 17, 18,000 miles an hour, you know, things can go wrong. So it's that constant thought, did we think of this? Did we think of that? Did we think of this? Because the slightest thing that could go wrong could actually mean this mission could fail.
Until very recently, the only planets we knew existed were the ones in our own solar system. But then, exoplanets, planets around other stars, were discovered. Thousands of them. And a new generation of astronomers realized they could use the telescope to study them.
With JWST, it started as this pure kind of idea for the cosmologists. They were going to look at the first ever stars that were born. And exoplanets muscled our way in to become one of the primary science goals of the telescope.
Most exoplanets are discovered using the transit technique. When a planet crosses in front of a star, the light dips by a tiny amount, and we know it's there. JWST is so sensitive it can detect the elements in the atmosphere of a transiting exoplanet by the way the light changes as it passes through that atmosphere. If there are elements necessary for life, the telescope could detect them.
As a kid, hearing that we were at this frontier of being able to search for life or signs of life made me feel like there was no other question worth answering. We're hoping that JWST is successful so that we can actually get some really astounding observations of these planets' atmospheres.
By the time the telescope was ready for the 6,000-mile journey through the Panama Canal to the launch pad in French Guiana, it had cost $10 billion. And NASA and its partners, the Canadian and European space agencies, were counting on it. Failure would be a disaster.
Good morning and Merry Christmas from the Guiana Space Center in Kourou, French Guiana.
It's a laser focus here in the control center as we get closer to launch.
I watched the launch from my mom's couch in Bee Branch, Arkansas, rural Arkansas, middle of nowhere. It was really beautiful. You know, the Christmas trees over in the corner, and it was, you know, a typical Christmas morning, except that we were all glued to the TV, you know, and I was on my laptop communicating with the team. I've been on this project for 14 years, and so I think all of us, as much as we trusted the engineers, all of us were a little on edge, or maybe a lot on edge.
NASA officials, including Rick Robinson.
It's the most violent environment you can imagine. We felt the ground shake, you know, felt the building shake and stuff like that.
Single point failure literally means if one thing goes wrong, you fail. There isn't a backup, there isn't an alternate. A dozen would be a lot. And we have 344.
I just want to confirm you see first motion.
I can confirm first motion.
Copy, just give us status as we move on down through the movement.
OC, you are go to fire. Whitman's go. All stations, this is Mom on Ops. We're a go at this time to finish sunfield tensioning.
Every hinge that has to move, every cable that is going to deploy a sun shield that's going to pull it out, 90 of those single point failures. If one of those didn't work, it literally could have been the end of the mission, and we just could have floated out into space as space junk.
Same thing I am. We have a primary mirror at this time.
Let me concur.
And we have a fully deployed JWST observatory.
We have a telescope in space. We've just unfolded The telescope. When I was 10, I was in the field. It was late at night. My mom was coming out to look for me. I didn't answer her, and I was laying on my back looking at the stars. I was looking at satellites crossing the sky. And my mom said, "What are you doing?" She got on her back, and I said, "You see that? Those things that are up there?" I said, "I want to fly one of those." I'm flying one of those now.
A million miles away in its cold orbit out at L2, the telescope now turns its golden eye to a tiny sliver of the sky, no bigger than a grain of sand held at arm's length. It's looking past the stars in our own galaxy into the emptiness of intergalactic space. It stares for 6 hours, the detectors collecting light from the distant universe. What it sees is beamed back to Earth in a series of ones and zeros over the deep space network.
Good morning, everyone. We are live, and this is it. The moment we have been working towards for 2 decades. The reveal of the first science images from the James Webb Space Telescope.
Okay, we've got the whole world watching. Are you ready to put the first image up? Oh, let's do it.
When the telescope stared at that dark sliver of the sky, it saw this.
So the first image is a deep field.
Except for a few spiky stars, these are all galaxies. They're all sizes and ages and colors. The deep field was designed to be a test of the telescope, and it was working better than anyone imagined.
All those dots that you're saying are not stars. The majority of them are galaxies. Cities, each one with about 100 billion to 300 billion stars on its own.
The brightest galaxies are part of a cluster 4 billion light years away. The light we see from them took 4 billion years to reach us. It left those galaxies around the time our solar system and the Earth itself was forming. But these aren't the farthest things we can see in this picture. Far from it.
The other thing that's extremely incredible is that the universe is providing us an even bigger telescope.
Little arcs, strange looking little arcs, curved things that don't look like anybody else's galaxy at all.
What you're actually seeing is the effect of curved space. Space like between you and me, where the geometry doesn't behave itself.
This is called a gravitational lens. Einstein said it should happen. He thought we'd never be able to use it for anything, but he knew it could exist.
A telescope is a time machine, and JWST is the most powerful one ever built. It can see deeper into the past than any telescope in history, revealing a hidden part of the universe. Galaxies glowing in infrared light from soon after the Big Bang.
There's a bunch of little red rubies all throughout the image. Oh, there's one. Okay, yep, they're here. Yes, this is going to work.
This picture is just a few pixels across, but it's a snapshot of the infant universe. And imagine being in the room when the telescope first beamed back what it saw to Earth.
This is what I get. It's a black square.
The image is there.
The image is here, but I just have to pull it out. The brightest regions are the only things you can see in here. So these are like the cores of galaxies and the bright stars in the image. And then as I bring it up, more detail starts to show up. You know, I was just like, I can't believe I'm the first person in the world to see what this is gonna look like from Webb. And it was incredible. Like, I just couldn't believe what I was seeing. It was
very moving moment, actually, when I like pulled myself out of the pixels and actually looked at the whole image. It was incredible.
The images emerging from the darkness reveal a whole new universe. An infrared universe. Invisible to the human eye. This group of galaxies is called Stephan's Quintet. They look calm enough at first glance, but JWST's infrared cameras capture what's really going on. 3 of the galaxies are crashing into each other in slow motion. They're colliding and merging. As they're torn apart, tails of gas and dust whip through space in torrents of fire. Looking farther into the infrared reveals something very strange. Glowing at the center of one of the galaxies is an enormous black hole. It's 24 million times the mass of our sun, and it creates a dent in space where gas and dust tumble in. The material circles faster and faster, emitting energy and light before disappearing into the darkness. Other telescopes, like Hubble, took pictures of galaxies. But JWST reveals their structures in intricate detail. Hubble saw the Cartwheel galaxy, but JWST can see the energy radiating outward like ripples in a pond from a collision that happened long ago. And Hubble saw the Phantom galaxy, but JWST reveals its skeleton, the clumps of gas and dust where a new generation of stars is forming. In the Tarantula Nebula, the telescope sees stars actually being born. They're still shrouded in the dust of cosmic birth, but infrared light goes through the dust, taking us into the stellar nursery for the first time. And the telescope can see the beginnings of stars much closer to home.
This image, yeah, this is the one that made me cry when I first saw it.
Astronomers call this place the Cosmic Cliffs because it looks like a craggy landscape on Earth. But really, it's a vast cloud of gas and dust being blown into this shape by the bright stars above it. They're young stars that have recently been born. The Cosmic Cliffs are in our own galaxy, only 7,600 light years away, nearby compared to the distant universe.
This one's part of our story. This is how stars are being born. Our sun came from something like that, about 4.5 billion years ago. Stars like the sun with planets around them are being born as we watch. Stars can die in there, and the circle will start again. So that's one of the enchantments about this place. These really bright stars here are so hot, they're burning off the surface of this cloud. And see the wispy stuff is coming up like steam off a pond in the cold winter morning. Is being vaporized by the heat of these bright stars. And a picture like that, it's just incredible details. There's things in there nobody's ever seen, ever. And they're features you can't explain. There's a thing that looks like a hook in there. Well, why has nature got a little thing that looks like a hook? No, I don't know. We'll find out. The picture is so different from what you can ever possibly imagine because it's so beautiful.
Like it's so beautiful. Like I'm almost I'm almost tearing up now because it's just.
So when you see it, what is it that's so beautiful?
This has always been there. It's always been out there, but we're just now able to see it. We now have this new telescope that's opened up our eyes to see something that we couldn't see before. I once was blind, but now I see.
The telescope has shown us how stars are born, and it also shows us how they die. When the fuel in the core of a star starts to run out, it becomes unstable. The star at the center of the Southern Ring Nebula is blowing off gas and dust in an enormous bubble that expands at thousands of miles an hour. And JWST found this star on the brink of a more dramatic end. It will soon go supernova, exploding in a fireball that can outshine the entire galaxy. This is the remnant of a supernova that could be seen in 1667, not long after the time of Galileo. The star is now gone, but its material has been blown into interstellar space, where it will be incorporated into new stars and planets in a cycle of birth and death and rebirth. The elements that made our sun and our Earth and us too were born out of exploding stars like this.
Our atoms are immortal, and we have been recycled.
We are recycled.
We are just recycled. We are recycled. It's okay.
We are the product of multiple generations of stars exploding and casting that matter out into space. And then that matter gets sucked up into the next generation of a gas cloud that's collapsing and forming a new star.
You know, you look up at the night sky and everything seems so distant and far away, but that's our origins. That's where we came from.
And this is one of the richest places new stars are being born in our galaxy. It's called the Pillars of Creation. The Hubble telescope took this picture in 1995, but it couldn't see through the dust. JWST sees right through it. The stars are formed when the gas collapses under the force of gravity, compressing into spheres that get hotter until nuclear fires ignite in their cores. This is a star just emerging from its cocoon. It looks a little like E.T.'s finger. And in fact, this is the touch of life.
Star formation is how we get the heavier elements. Atoms are literally crushing together to form the oxygen that we breathe, and the iron that's in our blood, and the calcium in our bones. It all came from a star.
We are made of stardust. The nuclear fires in the cores of stars and supernovas make the heavier elements. These elements become clouds of dust in the spiral arms of galaxies. We've seen clouds of stardust before, but only JWST captures them like this, drifting in the cool vastness of interstellar space. The instruments identified ice grains here that contain carbon dioxide, methane, ammonia, even water, the building blocks of life. The telescope took this picture of a new star system forming out of interstellar clouds of gas and dust. In the center is a line of material that spins as the star is born, the protoplanetary disk. The disk of stardust is the realm of new planets. Some will be gas giants like Jupiter, and some will be rocky like Earth. This is how our solar system formed 4.5 billion years ago. The telescope now turns to our own backyard, revealing new details about our planetary neighbors. The rings of frozen Neptune glowing in infrared light. Uranus, the only planet in our solar system, tilted 90 degrees on its side. Astronomers think this may be from a collision with another object in the distant past. Saturn, with its famous rings and a few of its 146 moons. Astronomers hope to find more, maybe even in this image. Jupiter, shrouded in clouds of frozen ammonia and methane, and its moons that Galileo saw 400 years ago. And then there are the asteroids.
Control system settling down, angular rates look really good.
The protoplanetary disk left behind millions of rocks circling the sun.
Looks to me like we're headed straight in.
A big one hit the Earth 65 million years ago and wiped out the dinosaurs.
Oh my goodness, look at that.
This is a video feed from DART, a probe NASA sent to try to deflect one of these asteroids.
Oh my goodness. 8,
Yeah.
7,
Oh,
6,
wow.
5, 4, 3, 2, 1.
By studying the explosion, the telescope and observatories around the world found that the path of Dimorphos had been altered. Now we know that if an asteroid is headed our way, we might be able to do something about it. The Earth is an oasis in a vast universe. In spite of all we've seen, it's still the only place we know there is life. The atmosphere of our world, with its delicate mix of oxygen and carbon dioxide, and its surface of water and rock, has made life possible. Could there be another living planet out there?
Are there any other planets like ours out there? Is there water, liquid water on the surface of another planet? Because that will be the first signpost of life.
JWST now turns to gaze at a star 1,300 light years away. Orbiting around it is a planet called WASP-17b. A team of exoplanet astronomers is finally getting some data back from the telescope to analyze.
So I'm gonna reveal the spectrum that we've got now. We are seeing very clear evidence of CO and water in the atmosphere.
The telescope detected water vapor in the atmosphere of WASP-17b, but this is no place for a vacation. It's known as a hot Jupiter. It's so close to its star that the planet is 1,700 degrees and the water is scalding steam. The team also identified quartz crystals and sulfur dioxide enveloping the planet in a thick fog. We won't find life on WASP-17b, but soon the team will be looking at another system entirely. 40 light years away lies a star system called TRAPPIST-1, with 7 Earth-sized planets around it. Unlike WASP-17b, the TRAPPIST planets are not made of gas, they are rocky, like the Earth. The planets closest to the star will likely be too hot to keep an atmosphere, and the farthest ones will be frozen solid. But there are 3 planets in the middle where liquid water could exist.
TRAPPIST-1 might be the best system that we will uncover in terms of being multi-planet, in terms of having all the vacation spots you can think of. Very cold planets, very hot planets. TRAPPIST-1 is pretty unique.
Pushing the telescope to its limits, the team is trying to detect an atmosphere around TRAPPIST-1e. An atmosphere hasn't been found on a rocky exoplanet yet, and it would be a big leap forward in the search for life.
The universe is so big, you know? I think there's no question that we're not alone.
There's just so many possibilities that statistically, I mean, you can decide for yourselves.
I'd take that bet in a heartbeat.
Are we the only planet where this happened? Are we totally alone?
Yeah, I think there's life out there. Can we find them? I think we will in my lifetime. God, I hope so. Because I want to know, you know?
Where did we come from? How did the universe begin? Are we alone? We've always wondered these things, and now, at last, we're getting answers. This telescope has transformed the night. We're close to seeing the beginning of time and space. We're close to seeing first light. We know there are as many as 1 trillion galaxies, each with hundreds of billions of stars and more planets than grains of sand on all the beaches of the world. We've always been a lonely species, floating in space, wondering, hoping, wishing, longing. Surely somewhere in the deep sky, there's another living planet, just waiting to be found. Any day now, we may find it.
I mean, it makes sense.
So, I hope you enjoyed that that film. Theo rightly noticed that my camera wasn't always recording, so I've got, I think, the majority of it. I managed to free up some space and sort that out. I think it's very interesting. It's an interesting point, isn't it? You know, are we alone? Do we have other planets out there to support life? Statistically, yes, we must have.
I mean,
the question I have though is this, right? This is quite a poignant question. This is quite a serious question, right? If there are other planets out there, right? Sorry, Thea, let me just get you the. Yeah. If there are other planets out there, and if they do have life like us, should we find them? Because if you think about it, the world is always at war with itself. You know, there's fights going on here, there, and everywhere, and all this stuff. Do we really want to have another? Do we want to have a planetary fight? Because that's what could happen. So are we better off not finding them, and not knowing, or are we better off knowing? It's an intriguing question, don't you think?
Yeah. I guess you just might as well find them and just leave them alone.
Well, yeah, but then they may not want to leave us alone. You see what I mean?
Yeah, but then they're fine to keep away if we looked at them or didn't.
Well, true. Yeah, better to be prepared, I guess. I don't know. It's a query. Leave a comment. See what you think. See what your opinion is. Right, we're gonna have another mooch round. Come on.
I've got to admit, there must be other life. I mean, it's impossible not to. The universe is infinite. I mean, it would be impossible.
It would make sense to me, wouldn't it? That there is other life forms. Right then, let's go
What's
and find
next
Grandma
is
Pops
to
and
see
see what's next.
Atlantis on NASA's bus tour.
Alright. I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
We have pondered our place amongst the stars since the dawn of humankind. We've looked at the stars with wonder and amazement, their glow guiding our travel for centuries. The more we learn about our universe, the more questions we have.
I'm Emily Calandrelli, and today you'll be following me behind the gates on this exclusive bus tour of Kennedy Space Center. Our journey will take us past active facilities and end at the visitor complex's own Apollo Saturn V center.
But before we begin this journey, just like every NASA mission, our #1 goal is to return home safely. So always stay seated while the bus is in motion. Please, no food or drinks on the bus with the exception of water. Please keep conversation to a minimum so others may hear and enjoy the tour. No photography is permitted at the security gates, but there will be plenty of photo opportunities during the tour.
This rocket that you'll see standing tall in front of KSC's badging station is the Mercury Redstone rocket. It represents NASA's earliest efforts to send humans into space. These Redstone rockets were formerly ballistic missiles provided to NASA by the U.S. Army. In October of 1958, NASA formally organized Project Mercury with the mission to investigate man's reaction to this new environment and safely recover the capsule and its pilot. Man rating for human spaceflight on what was previously a ballistic missile was no easy task. After several modifications and test flights, a Mercury capsule carrying Ham, a chimpanzee, was successfully launched and recovered on January 31st, 1961. Just months later, on May 5th, astronaut Alan Shepard launched on a Mercury Redstone rocket, becoming the first American in space.
Hi, I'm Janet Petro, and welcome to NASA's John F. Kennedy Space Center, where NASA astronauts have ventured forth on flights of exploration since the 1960s. And what an exciting time to visit our multi-user spaceport. Through our Commercial Crew program, we are sending astronauts to the International Space Station from American soil for the first time since the Space Shuttle program ended in 2011. We're continuing to launch new research experiments and supplies to the space station with our commercial resupply services and launching the most technologically advanced scientific instruments to date into space through our Launch Services program. This all culminates in our ultimate mission, the Artemis program, where NASA will return to the moon, this time with the first woman and first person of color, and continue on to Mars. In all our history, there's been one common theme woven throughout our DNA. It's our insatiable desire to explore beyond our home planet in our never-ending quest to expand our knowledge of the universe. As you venture behind the gates, you'll find a community of the most talented, dedicated, motivated workforce anywhere in the world who believe in the unlimited potential of space exploration. This is an active spaceport where new things are happening every day. You never know what you might see, so enjoy your tour.
You are now approaching the Vehicle Assembly Building, or as NASA calls it, the VAB. It is one of the largest buildings in the world by volume, and is the place where NASA completes the final assembly of its rockets before launch. The sheer scale of this building is hard to grasp, even when you're right next to it.
Do you ever feel really small when you think about space? What about when you're standing next to a skyscraper or a really big bridge? Well, I feel about as small as an ant right now. I'm standing inside the Vehicle Assembly Building trying to grasp how large it really is in here. It has 4 bays. Each bay has 2 large horizontal doors below it and 7 smaller vertically opening doors above it, tall enough to fit the world's largest rocket through. In fact, these are the largest doors in the world.
Construction of the VAB required 65,000 cubic yards of concrete, 45,000 steel beams, 1 million steel bolts, amounting to almost 100,000 tons of steel. Notice the flag painted on the outside of the VAB? It's the size of a 21-story building. The blue section alone is the size of an NBA basketball court. Each star is 6 feet across, and each red and white stripe is wide enough for this bus to drive down. And the entire VAB? It's so huge that the Roman Colosseum was fit on the roof with room to spare for a parking lot. By volume, the VAB can fit 3.5 Empire State Buildings, and it would take 250 billion ping pong balls to fill it.
Door is right here to your right there. You can see the door that's partially opened right there. That is where the crawler is right inside there that they're going to bring out there to the launch pad and pick up the mobile launcher, which I'll point out to you in just a little bit.
6 million pounds and capable of lifting and hauling 18 million pounds. The crawler is an engineering marvel, even without a rocket sitting on top of it. This thing has 2,750 horsepower V16 diesel engines that can carry the crawler up to a top speed of, wait for it, 1 mile per hour while carrying a rocket. Keep an eye out for the crawler as we approach this area. And remember, we are visiting a working spaceport, so while the crawler may not stay in one area for very long, it's bound to be out here somewhere. Now, let me introduce you to my friend, John Giles, the Crawler Project Manager.
I'm standing in front of Crawler Transporter number 2 at Kennedy Space Center. Crawler Transporter number 2 will be used for the SLS program to take the launch vehicle back and forth to the pad. We will begin by going underneath the mobile launcher. We'll pick it up, we'll take it over to the VAB. They'll then assemble the launch vehicle on top of the mobile launcher, and then we'll come back to the VAB. We'll slide underneath it again, we'll pick it up, we'll take it out to the pad, a trip of about 4.2 miles. It'll take us about 7 hours to get there. But during our trip to the launch pad, we'll roll over a specially prepared crawler way that consists of anywhere from 8 to 12 inches of special rock. Below that is limestone that's about 4 feet thick and compressed to hold the weight of the crawler and the mobile launcher. And then below that is some hydraulically compacted sand that can support all the weight. And then once we're there, we'll drop it all off. And a few days later, there'll be a launch. We'll come back, we'll pick the mobile launcher up, and we'll bring it back to the VAB to start the process all over again.
With 50 years and some 3,000 kilometers or 2,000 miles on the clock, NASA expects the crawlers to be in operation for at least another 3 decades. How cool is that? The latest refurbishment is complete, and preparation is well underway for the first SLS mission. The crawler will be doing what it was originally designed to do once again, which is moving rockets.
Off the ground. We stuck with it, and on May 5th, 1961, things finally started going right. Astronaut Alan Shepard took his ship Freedom 7 6.5 miles into space. America had its first space hero. Just a few days later, our space program received a new challenge. But this one did not come from the Soviet Union. It came from our young president. In one inspiring moment, he changed the mission from one based in fear of the present to one of hope for the future.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other thing. Not because they are easy, but because they are hard.
We hadn't been more than 16 minutes into space, and now we were going to the moon. We would have to design a rocket the size of a 36-story office building, put it together with the precision of a microscope, and accelerate it with the speed of a bullet. Then we would have to guide it to a moving target 250,000 miles away. Many people thought it was an impossible dream, but 400,000 of us set about making that dream a reality. It would be the longest, most hazardous voyage that any man had dared to attempt. But step by step, mission by mission, we orbited the Earth, perfecting the skills and technologies we would need on this incredible journey. Our astronauts practiced maneuvering, docking, and the 1,000 other tasks that would comprise the moon mission. We created new alloys, lighter and stronger than anything seen before. We designed communication systems that would be reliable over the vast distances. And behind it all, we tried to perfect the rocket that would be powerful enough to punch out of Earth orbit and take us to the moon. One day, however, the dream of flying to the moon almost slipped away. It was January 27th, 1967. Astronauts Virgil Gus Grissom, Edward White, and Roger Chaffee were on board Apollo 1 for a plugs-out test, a full-scale dress rehearsal for the actual launch. Suddenly it happened.
there was a fire in the capsule. 3 men whose lives had been in our hands were lost.
Surely the opening vistas of space promise high costs and hardships, as well as high reward. But this country of the United States was not built by those who waited and rested and wished to look behind them.
After Apollo 1, some thought we'd failed, and that the moon was out of our reach. But we owed it to those men to learn from their sacrifice and to carry on. We started taking the Apollo vehicle apart, piece by piece. Was the design flawed? Had safety been compromised? Tough questions. And we spent 1.5 years redesigning the spacecraft so that no astronaut's life would ever be at risk because we overlooked something, or because we could have done something better. A moon rocket is 91% high explosive, and it goes into the most unforgiving, hazardous environment there is. We could never make it risk-free, and the men who flew them knew that. We didn't send men into space again until Apollo 7 orbited the Earth, testing some of the new design. When everything worked perfectly, the decision was made. The next mission would travel to the moon. It was mankind's destiny to leave the shores of our planet behind and strike out across the vast ocean of space. In the great span of our history, now was the time that we could. Now was the time that we would. We stood on the eve of the longest, most dangerous journey that any man had ever undertaken. And it would be taken by Frank Borman, James Lovell, and William Anders, the crew of Apollo 8. Through those doors, you'll find the firing room, launch control, just as it was on December 21st, 1968.
Please gather all of your belongings in the front row.
So this is the actual launching room.
Isn't it incredible to think that your phone, that you could be watching this right now on, has more computing power than this entire room that sent a rocket up? Incredible.
This is the firing room, launch control for the Apollo mission. This is not a mock-up. These are the very consoles we sat at when men first took off to fly to the moon. The tragedy of Apollo 1 had put us 1.5 years behind. We were making up for it in one big leap, and we were doing it with a rocket that no man had ever flown before. It was a few days before Christmas 1968 when Apollo 8 sat on the pad. She was the first of a new kind, a moon rocket. This was the Phoenix, risen from the ashes of Apollo 1. The first Apollo crew did not die in vain. This was to be their testament. "36 stories high, she had been fully fueled throughout the night. The liquid oxygen in her tanks caused ice to form on the outside of the craft. The extreme temperature differences between the air and the sub-zero fuel caused the metal skin of the rocket to expand and contract. Everyone who was on the pad agreed. It was as though the rocket was alive, breathing, straining at the leash. Earlier in the morning, astronauts Frank Borman, Jim Lovell, and Bill Anders had made their final preparations before taking that long ride out to the waiting spacecraft. The minimum safe distance from a Saturn V at liftoff was 3 miles. The reason was simple. When fully fueled, the rocket contained the explosive power of an atomic bomb. As the clock counted down, the astronauts and all of us in launch control went through the pre-flight checks. Our hands on the controls of the most powerful, most complex machine ever built. It had over 2 million separate systems. And to bring these men back alive, everything had to work perfectly. Each individual system had been tested, but what we didn't know was how they would perform when all 2 million began to work together. That moment would come when the countdown clock reached 0. If a maneuvering thruster failed, if communications broke down, if navigation was off by 1 degree, if any piece of the miles of wiring, circuits, relays, or valves was defective, Frank Borman, Jim Lovell, and Bill Anders would pay with their lives. As they sat, waiting for launch on that chill December morning, these 3 astronauts were back to what they had always been, test pilots. You are now in the final minutes before the launch of Apollo 8, right here where it actually happened. Mankind is about to leave his planet behind and journey to another. It is one of those rare moments when history is not being made, destiny is being embraced.
Attention all personnel, the countdown clock will start on line mark at T-minus 3 minutes. 3, 2, 1, mark.
This is launch control, T-minus 3 minutes and counting. We have completed our communications checks with the Apollo 8 astronauts in the cabin, and the communications are go.
Verify effectively off, T-minus bar. T-minus bar, you are cleared for firing command.
During this period, once we do get the firing command, the various tanks within the 3 stages of the Saturn V launch vehicle begin to pressurize.
Firing command enabled.
We have firing command. The firing command is in. We are now on the automatic sequence. T-minus 2 minutes, 20 seconds, and counting. Our status board indicates that all aspects are ready. Instrument unit is ready. Spacecraft ready. Final check of the emergency detection system. That ready light also on. First stage preparations are completed.
All systems remain okay.
Keep going. We're on. Ready to go to convoy. Stand by water. Okay, you're on.
All systems go.
1 minute, 45 seconds and counting. The first stage liquid oxygen tank has been pressurized, and the pressure is still building up. Coming up in 90 seconds, mark, T-minus 90 seconds and counting. The Apollo 8 crew standing by, spacecraft commander Frank Borman, Jim Lovell, Bill Anders. We now have a report that the liquid hydrogen tank on the 3rd stage is pressurized. 1 minute, 15 seconds. All 3rd stage propellants pressurized at this time as we come up on a 60-second mark on a flight to the moon. T-minus 60 seconds and counting. The vehicle now is completely pressurized. We're coming up on a power transfer shortly. We have the power transfer. We're now on the flight batteries within the launch vehicle. Final reports coming from Frank Borman at this time. Final look at the switch list aboard the spacecraft. 20 seconds, all aspects. We are still go at this time. T-minus 15, 14, 13, 12, 11, 10, 9. The ignition sequence start. The engines
shutters vibrate and glow orange to show you basically what it was like for them when the launches were happening.
Liftoff at 7:51 a.m. Eastern Standard Time. We have cleared the tower.
Apollo 8 successfully orbited the moon, and the astronauts returned safely to the Earth. I know. I'm Jim Lovell, and I was one of the crew of this spacecraft, Apollo 8. We were the first men to see the surface of the moon from just a few miles away. But it was the hundreds of thousands of men and women who worked with that team, and the millions of people who supported the mission that really made it possible. That way, I guess, we all went to the moon. Now, on the other side of those doors, you'll find an actual Saturn V moon rocket. It's still the most powerful, the most complex machine ever built. And I guess it's the only one that can take you to another planet. I actually got to fly one on a second flight to the moon called Apollo 13. But that's another story.
Ladies and gentlemen, may I have your attention, please? The next presentation in the Lunar Theater will begin in 3 minutes. If you would like to join us, please proceed to the nose end of the Saturn V rocket.
We thought we'd walk the length of this rocket just to show you just how massive it is.
Still going.
You can't really get your head around it without seeing it close up. It is colossal.
Only on the second compartment. Go around there.
Is that how old it was? 3.6 billion years old. Oh my gosh. Yeah.
So this is the crew hatch provided a proper seal. Nope, didn't read it quick enough. What's it like, dude?
It doesn't look like it has many seats in it.
3?
No, it doesn't look like it has any.
I think they did have 3. Probably removed them. That's a cosy living.
Yeah, I guess so.
Wow, it's quite amazing how you learn a lot of stuff here. It's quite stunning to see all of what was done, what was made, man-made. It's incredible, really, what people can do when they put their minds to it.
It's humongous. And just to think, the
Yeah.
which you may have saw, by the way, literally could fit hundreds of these. Well, not hundreds, but you know, loads of them. Oh my gosh, it's got a mini version.
Yeah.
I've got it.
They would burn for about 6.5 minutes. They would put down the third stage.
So that's that building that they build them in. You've got one launch site and another launch site, which I think these are the ones, one of those, I think is that one there, is the one we saw the SpaceX go from, I'm pretty sure. I'm not 100%, but I think it was that one. Very faint because of the light. Oh, there we go.
After Elon Musk
There.
sent his first SpaceX, none of them have gone wrong. Well, the ones.
Well, there was a lot of troubles with the ones that they were practicing with, but yeah, you're right.
After the practice,
Yeah.
they were always working.
They learned, definitely.
Yeah, it stopped crashing completely. Never, not once. Because, you know,
So this is one of the lunar cars. Commander Gene Cernan driving the lunar rover during the last mission. So there you go.
do you know, not one moon buggy could have.
How cool is that? The little tyres are made of mesh.
Yeah. They have to develop a whole new type of tyre to let these things drive on the moon.
Really?
Yeah. A whole
I don't think much to their seats.
Yeah, I think
They
that's
don't,
pretty horrid.
they don't look like much padding, do they? And then you've got his astronaut suit.
Oh, that must have been tight.
Yeah, that's cozy. Wow. Well, this is rather theatrical. Pair of RX-1 arms. These arms were part of the advanced Apollo suit called the RX-1. Wow.
They also use it to study stuff with moon rock that might be highly explosive to use in a box they put their arms
Are
through.
you making that up, or do you actually know that?
Actually, no, it's
Oh.
it's a very similar design apart from the one that they actually use is made of rubber, not metal. Tin cans.
Wow.
And they're very thick. Yeah, they look a bit like that.
Alright.
That's his watch.
Yeah, it's not working anymore.
What do you say? Up there.
Lunar sample. Apollo 17, December 7th to the 19th, 1972.
And 3.7
This
billion
basalt
years old.
sample, estimated to be 3.7 billion years old, was collected by astronaut Harris Schmitt near the Taurus Littrow Valley region of the Moon. Wow.
Sounds a bit like a swimmer.
Look at that. The Apollo 14 capsule. So there you go, you've got three seats in that.
And it's complex looking.
I was supposed to say, look at that door.
You'll be worried you've broken something, wouldn't you? When you're back?
Yeah. Wow. Look at all the little boost things on the side. See the little holes?
Yep, stabilizers.
Yep.
Yeah, but you-
Incredible.
That would be worrying.
You've got to be either brave or mad. Or a bit of both.
Yeah, probably both. Mostly.
Houston, over.
Houston, Columbia, Ridge, last clear, how many?
We're standing by for Eagle. Okay, come on. Copy out. Yeah, my controllers, we're off to a good start. Light cool. ALS left. Roger, ALS left. Here's Eagle, out of your reach. Bye, Eagle, we're standing by for your burner report, over. Roger, the burner's on time.
As soon as the Eagle reappears, things begin to go wrong. Radio communications break down. Messages to Eagle must be relayed through Mike Collins aboard the command module Columbia. Throughout the crucial final checks, contact with the Eagle keeps dropping out. And Flight Director Gene Kranz inches closer to aborting the mission. With the vital computer links temporarily holding, the moment of decision is now.
Okay, all flight controllers, don't go for landing. Retro, go, I don't go, I go. Control, go, Telcom, go, GSC, no, Econ, go, Surgeon, go, Capcom, or go for landing. Eagle, Houston, you're go for landing, over. I understand, go for landing. 1, 0.
Hurtling toward the moon at 3,800 miles per hour, Neil Armstrong notices his checkpoints are all appearing too soon. This means a serious navigation error. At these speeds, 3 seconds long means missing the safe landing zone by 3 miles. Suddenly, the computer starts firing the maneuvering thrusters, jolting the ship back and forth. This has happened in simulations, but never this much, never this violent. The smooth descent is becoming a bumpy ride. Before that is fixed, a problem with the onboard computer. The astronauts have rehearsed for thousands of possible malfunctions, but not this one. It had been considered too unlikely. Seconds seem like hours as everyone struggles to remember the meaning of a 1202 program alarm. The deadline to safely aboard is vanishing fast. 1202 means the Eagle's onboard computer is overloading. This means Houston is blind, unable to make navigation corrections or interpret the data coming from Eagle's computer. Armstrong and Aldrin are on their own. Mission Control decides they can go ahead if the data link doesn't fail again. 1,000 feet, and Neil Armstrong can see that the computer is proposing to put them down in a dangerous place. That landing site is full of boulders. If they land there, they will never take off again. At 350 feet, Armstrong ignores his computer navigation and veers away from the rocky landing site with no time to explain to Mission Control.
Okay, I'll flight controller, things good.
In Mission Control, everybody is stunned. At 300 feet, the Eagle has left its flight plan and taken off at full speed across the face of the moon.
Eagle Houston is C-2 fuel, monitor, over.
90 seconds of fuel remaining. Now less than 200 feet, and the Eagle is too low to safely abort back into orbit. They call this part of the flight plan Dead Man's Curve. All that's left for Mission Control is to read off the fuel remaining in seconds.
60 seconds.
The entire moon landing has come down to 2 men and 1 minute.
Forward. Quick speed down, 2.5. After 30 seconds. 30 seconds. Lights on. Down 2.5. Forward. 3 feet, 2.5 down. Straight down. 4 forward. 4 forward, switch to the right, go. 9.5. Contact light. about to be on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
A short time later, history is made again.
Okay, Neil, we can see you coming down the ladder now.
For one incredible moment, we are one people with one history, watching our destiny unfold.
One small step for man, one giant leap for mankind.
Armstrong is on the 38-year-old American.
It was a moment shared by an entire world.
Pyramids of the planet Earth, first set foot upon the earth. It came in peace for all mankind.
With these first steps, mankind stood on the highest ground, and we saw our planet as our home port in the endless ocean of space.
There was something which was surprising to me. That occurred as I was standing on the surface. Just after we had landed, I'd gone down, standing on the surface and looking at planet Earth for the first time, seeing the beauty, seeing the finiteness of it, the limits of it, realizing what a shame it was that people were confronting each other on that planet without realizing what it was doing to the planet. It was a very emotional moment for me. I actually shed a couple of tears. Something totally unexpected for an engineer and fighter pilot to be crying up quietly up there on the moon.
Mankind had achieved a tenuous foothold in the heavens, and a new and exciting world lay waiting to be explored. The first mission had stayed for only one day, but over the next 3.5 years, 5 more Apollo missions visited the moon, and with each one, we stayed longer, roamed further, and discovered more.
I never thought when I was a kid building rockets, in high school, that we would go to the moon, before the end of the century. I mean, I thought that was something that was way in the future, fantasy.
I was rolling on the moon one day.
They're enjoying themselves way too much.
We've got to understand that as a people, we need to stretch. We need to reach beyond our grasp. We need to strive to do things that seem impossible, because in the accomplishment of them, we move society forward.
One of the astronauts has said those hills that we climbed give our children and grandchildren a different perspective, that they see the mountains that we couldn't see. And so what we considered impossible, they're dreaming about.
3, 2, 1. What a ride, what a ride.
When I have a chance to talk to kids, the first thing I tell them is to take the word impossible out of their vocabulary. Go to their teacher tomorrow morning and scratch it out in the dictionary. The word doesn't exist. If I could stand here and tell you that I lived on a moon, that I called the moon my home for 3 days, you tell me what is impossible in this day and age, much less in a generation that follows, much less into the 21st century. Nothing is impossible.
I like exploring things, inventing. I would like to go up there, find out what's really up there.
I would like to be an astronaut. I like to design rockets.
Payload specialist.
I'd be a ground control officer. The thing that my mom can't understand is I'm terrified of heights, but I want to be an astronaut.
There's so many things I'd love to do. I would explore, I'd look for everything. I would try to start a farm. Millions of other galaxies that you might be able to live in.
It's the unknown. Anything's possible.
You may be able to cure certain diseases. Mars and dance on it.
Play basketball, but you can still be short. You can
because then you could like fly up in the air.
Baseball would be awesome. Hit the ball, you get a home run every time.
There are a lot of things that can benefit mankind that we, because of science, we simply cannot do on Earth.
It's such a big universe, and it's kind of strange to think that just this one tiny planet was chosen to have life on it.
I hear they're finding new planets or moons, and they're finding out more about how stars are working, and it makes me feel like it's trying to tell me something.
What's it trying to tell you?
That you belong up there with them.
The Apollo program ended in December of 1972, but our journey into space is just beginning. I'm Neil Armstrong. The future of space travel is being written right now in the dreams and imaginations of a new generation. Perhaps that's the greatest legacy of Apollo. It shows our children and grandchildren that with courage, imagination, and the will to explore, no dream is impossible.
Go. This is Theo getting to touch, and I'm going to do it too. A lunar sample, so this is a bit of moon rock. My phone stops acting up.
Stronger than normal rock, I must say. Very smooth.
Wow. It is very smooth, I expect that's probably from everybody. Footprints on the moon, footprints on the moon.
Hey, if focus the camera just quickly.
I am.
I am walking on the moon. My big footprints.
Where are those, my feet? That's cool. But yeah, to be able to touch a little bit of lunar. So this is the lunar module cockpit. It's insane.
So small.
Hey?
So small.
It's very small, isn't it? It's cozy, I would say.
The first
Oh my days.
Is that real?
No, I think it's a mock-up.
Oh,
I think they did say it was a mock-up.
Just show a picture of it next to that.
Want to reduce the CO2 buildup?
We need a better safety margin. The crew can tolerate a short-term increase, but...
Engineering? Morning, Betty. What, right now? Building 36?
I didn't even know there was a building 36. Must be important. Everyone's here. We have propulsion, aerothermal, flight dynamics.
Anyone know why we're
Jesus, Theo, my back.
for this?
Blew my neck.
Good morning. We're going to create America's next spacecraft. It's going to launch like a rocket and land like an airplane. And it's going to be reusable. Can you do that with a rocket? It's not a rocket. It's a shuttle.
Now it's time to go to the next step. From sketch pad to launch pad. Going to the moon was a camping trip. Now our job is to work and live in space. This vehicle has to do something that we have never done before. perform 4 key tasks, and be able to do them over and over again. There is nothing easy about putting a ship back up into space, let alone a whole fleet of ships. But first, let's talk about the launch. We have never designed engines and vehicles that can be reused. But we will, and once we're in orbit, we go to work. We want to take all kinds of cargo up there in addition to the people. Science labs, satellites, even the space station. And when all the work is done, we gotta bring everybody back home.
All right now. The country's waiting. Let's build ourselves a spaceship.
It's too big, it's too heavy. But we're launching one spaceship on the back of an even bigger one.
What if we split the booster into its pieces?
Rockets, fuel tank.
It's supposed to be reusable. How do we get all those parts home?
What if we just throw the fuel tank away?
We're running all new processes, procedures, manuals. We've never had to reuse a ship before.
Also, we're gonna have to build some really big garages.
Sir, what if she lands somewhere other than Florida? How does she get back here? To Glider?
Buy her a plane ticket home.
Our ablative heat shields are heavy, and they burn up on re-entry. We need a more reusable solution. Silica foam tiles, thousands of them, fitted together in one lightweight, reusable heat shield.
Another holdup with the engines? Tell me some good news with the tiles.
The heat shield bond keeps failing. The tiles keep falling off.
So another delay. How long? How long?
1.5 to 2 years.
Well, this is going to be fun to tell my boss. Everybody get back to work.
How do you feel?
I'll let you know. When they come home.
The President's message said, "You go forward this morning on a daring enterprise, and you carry the hopes and prayers of all Americans with you." And Astronaut John Young, the commander of the mission, replied, "That's a right fine speech. We sure appreciate it."
The launch of Columbia marks NASA's first manned test flight ever flown into space with the people.
Hey,
me emotional.
Really?
Yeah.
Why?
I don't know, just does.
The first one would make me emotional a bit, but that one, I enjoy that one.
Wow, look at that. It's incredible.
Oh my god. It just proves how big you have to make mine. They must have the fuel very compact to fit that in there as well.
The size of this thing.
That's pretty big.
And it's just suspended from the ceiling from cables.
Oh, not go under there.
The orange tank goes in there, but you get rid of the orange tank after 8.5 minutes. It's
Has anybody here ever seen a shuttle launch before? TV, video, YouTube,
American return to space.